Hi everyone, my name is Ankit Chaurasia and I work as a senior software engineer at Astronomer. I work in DAG authoring team and have also worked on implementing various deferrable or async operators for various providers in Astronomer provider repository. So I have been using Airflow for more than a year now. That includes building data pipelines with Airflow and also contributing in Airflow as well. And part of what I bring to this talk was to share my experience with the community in writing deferrable or async operators for various providers, its ecosystem, and various challenges around it. Before that, let me talk a bit more about me. So I'm pretty new to Airflow. I have started using Airflow since April 2021. I also try to contribute on Airflow in my free time. Before this, I had been leading engineering team across multiple projects in healthcare and agriculture domain at Wadhwani AI, which is a non-for-profit research institute developing AI solutions for social good. Prior to that, I had worked with multiple startups focused on AR/VR applications, camera applications, SDKs, drone data analysis, and I was also a founding engineer at a startup in home improvement space where I worked on building web-based applications that leveraged classical ML models. So outside work, I love traveling, uh, cycling, cooking, watching random documentaries, and so on. Uh, Originally, I'm from Nepal, but I work in India. Both Nepal and India are beautiful countries, and I would love to encourage you to visit at some point. So, more than that, now let's talk about this talk. So, broadly, I have divided my talk basically into 5 different sections. Uh, we will start with standard operators or traditional operators. We'll touch upon the issues around it. Next, we'll talk about the motivation for deferrable operators and high level concepts around it. Then we'll deep dive into deferrable operators. I'll also demo the code and the implementation for one of the deferrable operators. Finally, we'll talk about various pitfalls and learning in the whole process for implementing the deferrable operators. Now let's get started by talking about standard sensors and operators. Standard operators and sensors take up a full worker slot for the entire time they are running, even if they are idle. So sensors have two types of mode, poke mode and a reschedule mode. So let me give you a scenario. Let's imagine that you have 100 worker slots available to run the task, and you have 100 DAGs waiting on a sensor that are currently running but ideal. Then you cannot run anything else, right? Even though your entire Airflow cluster is essentially idle. Reschedule mode is used in order to avoid the situation when all the worker slots are reserved for the sensors. However, if you have hundreds of sensors running in parallel, you'll reach a certain limit, and even with the mode set to reschedule, you won't be able to trigger more uh, tasks. Now let's talk about other real world example. So traditionally, a task may submit a job to an external system. So in this case, you can see it is a Spark cluster, for an example. And then the post status of the job is done until the task is completed. So even though the task might not be doing something significant, right, or any significant amount of work, it would still occupy a worker slot during the polling process. As the worker slot becomes occupied, the tasks may be queued, resulting in the delayed start times. So this is where the concept of deferrable operators is very useful. A deferrable operator has an ability to suspend itself and free up a worker when it knows that it has to wait and hand off the job to resuming it to a trigger. So deferrable operator framework has been released as part of Airflow 2.2. So you might be wondering, why am I talking all this? Why deferrable operators and sensors? So one of the major reasons I started with was to save my money, save dollars essentially. So there will be massive resource saving for long running operators. For example, it could be Spark based operators, S3 sensors, and so on. So how am I saying this, right? So ideally, we conducted an experiment to measure the impact of using deferrable or async sensors via a triggerer compared to a regular sensors that occupy a worker slot while running. So our hypothesis was that we will observe a lower slot consumption on deferrable or async operators. So the metrics we used here was the total number of minutes a task spends running on a worker slot, summed over all the tasks slot uses in seconds. So we used a file sensor. One task waits for a file and another creates a file. We created a separate pool in Airflow. We had reused default pool for the file sensor, and used a new pool to create the files. And we created DAG with thousands of group tasks. So from this benchmarking experiment, we plotted this graph. You can see. So the number of worker slots waiting increased drastically in case of normal sensors. You can see with the blue line here. And in async sensors, the number of worker slots remained constant, which is represented by the orange color here. So based on these observations, the longer the sensor waits, the more efficient the async sensor is. We can improve it further by fine-tuning airflow configurations as well. So my recommendation would be, if you have a sensor that has to wait for a long period of time, you can enable the triggerer and use the async sensors comfortably. Now let me move on to the next slide. So let's talk about like few important concepts for deferrable operators. So let's start with trigger. So trigger is essentially a small piece of asynchronous Python function which quickly and continuously evaluates a given condition. Thousands of triggers can be run at once in a single process, which is triggerer. So in order for an operator to be deferrable, it must have one trigger code that determines when and how the operator tasks are deferred. So next bit is triggerer. So triggerer is a new service in Airflow, like a scheduler or a worker, that runs a async IO event loop in Airflow environment. Running a triggerer is essential for using deferrable operators. The triggerer is responsible for running all the triggers and signaling tasks to resume when the condition has been met. Triggerer by design is very highly available. So now let's move on to the next important bit, which is async IO, which I mentioned, right? So async IO is a Python library, which is foundation for multiple asynchronous framework. It is core. It is core to deferrable operators functionality and is used when writing triggers. The next important concept is deferred. So this is like a new Airflow task state, which is represented by medium purple color in the Airflow UI. I'll showcase that in my demo section of the presentation. This has been introduced to indicate that the task has paused its execution, released the worker slot, and it has submitted a trigger to be picked up by the triggerer process. So how does deferrable operator work? The task is picked up by a worker. The task defines a trigger and a defer function of checking some condition to the triggerer. The triggerer runs the task trigger periodically to check whether the condition has been met. Once the condition succeeds, the task is again queued by a scheduler till the task finishes, right? So next, we can see that with deferrable operators, the worker slot can be released while polling the status of the job. When the task is deferred, or when I say deferred, it could be, you could understand it as the task is suspended, right? The polling process is offloaded as a trigger to the triggerer, freeing up the worker slot. The triggerer has potential to run many asynchronous polling tasks concurrently, preventing this work from occupying your worker resources. When the terminal status for the job is received, the task resumes taking a worker slot while it finishes. So visually, you can see this in this diagram here, right? Next, we will talk about basically some considerations while writing a deferrable operators. So deferrable operators and triggerers rely on recent async IO features. As a result, it would only work on Python version 3.7 and higher. You also need to ensure that Airflow installation is running with at least one triggerer process as well as a normal scheduler. Your operator must defer itself with a triggerer. If the trigger is in the core Airflow, you can use it. That's great. Otherwise, you'll have to write one. Apart from that, you also might need to write your async hooks for that operator, right? Which you are trying to implement. And there shouldn't be any sync operations inside the triggerer as well. So now let's discuss about the structure of deferrable operator. So usually a deferrable operator inherits from base operator class of Airflow. So this class has a constructor, an execute method, and execute complete method. So execute method here fires the task deferred exception and suspends its execution at some point in the future, right? And execute complete method basically is responsible wherein like the trigger has finished its execution, it would kind of come back to the worker slot. So if you want to trigger deferral at any place in your operator, you can call self.defer, which raises an special exception that Airflow will catch. So here there are like 4 arguments you can see, right? So basically there would be like 4 arguments in case of like defer method, right? First one is trigger. So trigger is an instance of trigger which you used to defer on. It will be serialized into the database. Next is method name, or like it's a callback function, right? So this method name is so the method name on your operator you want the Airflow to call when it kind of resumes, right? And you can also pass in the additional argument using some quirks. And there's a timeout argument as well, which you can basically specify, after which the deferral will be timing out and the task instance fails essentially. So now let's talk about triggers. Trigger is basically written as a class that inherits from this base class, which is base triggers. And it has got 3 methods. First is initializer, which is an init method, which would receive an argument from operator instantiating it. And run is basically our coroutine that runs its logic and yields one or more trigger event instances as a synchronous generator. And there's a serialized method which would return the information needed to reconstruct this trigger as a tuple of class path and return the arguments to pass to the initializer, which is the init method. So in this code snippet, you can see this is a simplified version of date time trigger. So there are few design considerations to be aware of. The run method must be a synchronous one, and it should correctly await whenever it does a blocking call or any sort of a blocking operations. Run must yield its trigger event, and it should not return them. So if it returns before yielding at least one event, the Airflow will consider this as an error and fail any task waiting on it. If it throws an exception, Airflow will also fail any dependent task instances as well. You should assume that trigger instance may run more than once. This can happen when, let's say, you have a network partition occurring or Airflow kind of relaunching the trigger on a separate machine and so on. So you must be mindful about the side effect and implement your triggers accordingly. So this is one thing which I have personally faced multiple times during my implementation, right? So for the operators, we cannot pass a class object to a trigger because the serialized method only supports JSON serializable object. So it will be serialized into the database. So it's really important to like pass in the objects to the trigger, which is JSON serializable only. Now let's talk about hooks. Hooks provide an interface to interact with external systems, but they do not contain any logic for how the system is interacted with. Operators rely heavily on hooks to interact with any sort of external systems. So for async or deferrable operators, writing a async hook that operator will use is really necessary. Moving on to next slide, I'll do a demo for S3 key sensors async. So S3 key sensor basically waits for a key to be available on a S3 bucket, and I will demonstrate how to do it asynchronously using a deferrable S3 key sensor async. So in this step, I'll basically be doing two things. First, I'll demo the example DAG for S3 key sensor async, and next I'll give you a code walkthrough for S3 key sensor async. This is my Airflow dashboard. So I have been running Airflow locally, and so using the Docker container. So this is my triggerer, right? You can see right now, it's not running anything, right? And I have a worker, right? Web server, scheduler, basically a Redis, as well as a database, right? So I have already implemented a S3 key sensor async, right? So what it would do is it would essentially keep on polling the S3 bucket for the existence of a particular file. And I'll be using that in my DAG as an example here. So this DAG first essentially creates a S3 bucket. It then uploads the file from local file system to the S3 bucket. Then it checks for that existence of that particular file. And this is async. And how do I know that? Because it would show a deferred state, and it should also reflect upon my triggerer log as well, right? So let me run this task. All right. So now you can see it's creating the bucket. And by the way, this is the deferred state, right? In purple color. So it is now uploading the file from local file system to S3 bucket. Now it is running, checking for the existence of a particular file. Now it did differ. Now let's check the trigger log. Right. So it's poking for that file, right? It did find the file, right? Okay. So it did complete the task. So it will keep on going through the particular tag. So now let's dive deep into the code. So this S3 key sensor async class inherits from the base operator. The constructor here, the init method, I have added basically the bucket name and the key I want to look for, and wildcard match, basically for wildcard based matching. And I also look for the AWS connection ID. And like I mentioned, I also have an execute method. So first step, I basically resolve for bucket key and bucket name based on if they are valid or not, right? And then next, I basically pass it on to trigger, right? And how do I do that? I do it using self.defer method, wherein I basically make a call to this S3 key trigger, right? And as S3 key trigger is also inherited from this base class base trigger, right? And this is my constructor again, right? Next, I have the serialize method, and in this method, right, I basically return the S3 key trigger arguments and the class path. And it's quite important to have the right class path. I personally have faced this multiple times wherein this class path was wrong and my Airflow log was throwing some random weird errors, and I took a lot of time to debug. And also remember that this should be JSON serializable, right? So a class object cannot be essentially passed here, right? Which is not JSON serializable. And I have another coroutine, which is run method here, right? So the first step, I basically get a sync hook, which is S3 key, S3 hook async, which I'll explain it afterwards. Once I got that hook, I basically create a connection, a sync connection, right? And then I check for the existence of a key, right? So again, if the user has passed for the wildcard match, we'll look for the wildcard match. Otherwise, if the user hasn't passed any wildcard match, right? In that case, I'll check for the key, right? And here I basically await for the existence of that particular file, right? Yeah, if I found the file, I basically return true. Otherwise, if I get an error, I return false, right? So here, if you look at it, right, if I found that particular file, right, then I yield this success, status as true. And whatever I have yielded here, right, it will be shown as a callback, right, here in execute complete method, wherein I will basically show the corresponding response if it's success, or if it had failed with certain error, I would also show that error here. Now let's look into the hook. So again, this hook inherits from AWS base hook async, and this AWS base hook async also inherits from AWS base hook, which is a synchronous hook, right? What I'm doing here is I'm just getting the creating the async connections using AIO Boto core. So AIO Boto core is again a synchronous library which I have used to create AWS connection asynchronously. Now I have this check for key method here, right? And which I had called from the trigger. Here I basically await for the client to wait for this particular object in a particular bucket, right? If I found that, I return true, otherwise I return false. So this essentially is a coroutine, right? So this was like the brief walkthrough of the basically S3 key sensor async. Now let's move on to the next section. So few considerations while writing async or deferrable operators. Any deferrable operator implementation needs an API to give you a unique identifier in order to poll you for the status in the triggerer. So this does not affect creating a async sensors, as sensors are just poll based, whereas like operators are like you submit something and then you poll for something, right? So it's submit plus poll based kind of operation. So in the code snippet, you can see that this is a snippet I had taken from Google BigQuery API, BigQuery, operator. So here at first, like I basically get the, basically I submit the job and I get the job ID, and then I basically pass on this job ID to the BigQuery get data triggerer, and this triggerer will essentially keep on polling for the status of that job. And your operator must differ itself with a triggerer. If there is a triggerer in the core Airflow, that's obviously great. But in case if you do not have that, you might need to implement one of them for yourself. You can also differ multiple times, and you can differ before and after your operator does significant work, and only differ if certain conditions are met. So this has to be taken care by your trigger. Any operator can differ, so no special marking on its class is needed, or it's not limited to the sensors as well. One of the important things to take care of is you can see if the official library supports async. If not, you might need to find the third-party library which supports async for you. So to give you an example, Apache Airflow providers Snowflake library installs Snowflake connector Python library as well, which officially supports async call for you. But in case of AWS, Boto 3 natively does not support async call for you. So there's a third-party library which I looked up for, which is AIO Boto Core, which I used in my S3 key sensor async implementation, which I showed you earlier, right? And this supports the async implementation. So you might need to look up for the async libraries for yourself. And again, the next important bit is you need to also be cautious about inheriting the sync version of operator wherever possible, so that boilerplate code can be avoided while keeping the consistency as well. So now let's talk about some pitfalls. So from the operator, we cannot pass in a class object to the trigger, because the serialize method will only support the JSON serializable values. Another important thing to kind of take care is that at times the async implementation might require calling the synchronous function, and for this we use asgraph sync to async function wrapper for this. Sync to async basically lets async code call a synchronous function, which is run in a thread pool and control return to the async coroutine when the synchronous function completes. Another important point which I want to highlight again, which I have already discussed, was while implementing the trigger serialize method, it's important to use the correct class name. Otherwise, your worker log will show really weird error and it will be really hard to debug. And I have faced this in past a lot of times. So now let's move on to the benefits of deferrable operators. So the first one definitely is reduced resource consumption, right? Because the number of workers needed to run the task during the period of high concurrency will reduce drastically. That will lead you to like save your resources as well as money as well, right? And resiliency against the restarts. So basically, let's say if your deferred task will not be set to failure state if the trigger needs to be restarted due to the deployment or the infrastructure issues. And it also is useful in events with event-based DAGs as well. So now let's talk about when should we use deferrable operators. So we can create async operators for any sync version of operator where we want to do some sort of polling, right? Wherein that task takes certain amount of time to complete and we want to keep on polling the status of that task. But for an example, we want create a async operator for, let's say, BigQuery create empty table operator, because it will take really small amount of time to run that, right? So like important use cases for deferrable operators could be like file-based operations, any input-output bound tasks, right? Network-backed operations, basically any DB operations like executing a long-running query, poke operations, and so on. So one thing to keep in mind is that we want to make our implementation for deferrable operators in such a way that these operators are drop-in replacement for its basically non-deferrable version of implementation which is already existing there, right? So one example here could be something like this, right? I basically use S3 prefix sensor async as it is in the code as S3 prefix sensor. So the rest of the code does not need any change as required. The package astronomer provider repository is a really interesting one. We already have implemented around 24 async operators and sensors, which are publicly available, by the way. And we are continuously adding more. And you can please join the OSS community to add more along with us. So also, astronomer provider repository can be a good source of inspiration if you want to get started with deferrable operators, I would say. And during this whole basically journey of writing deferrable operators, there are a couple of links and references which I found personally very useful for me. So one of them was just to understand the concept of async IO in Python, right? The concept of concurrency, and again, like various documentations as well. I have already like shared the links here. So the first link here is a really nice blog which provides you a perfect analogy which will help you to understand Python-based async IO library and how it works, right? So now that was, I think, the whole talk about deferrable operators. Let's move on to like Q&A section. I'd be more than happy to answer any of the questions which you have along the way.